Function transformations. You know who I am. I ain't gotta say it. So let's go ahead and start it off. So apparent function transformations. What is apparent function transformation? First of all, apparent function transformation works for all 6 parent functions. In this situation, we're looking at the absolute value. The quadratic. Excuse me, quadratic. So this works for the absolute value. It does work for the absolute value. It does work for the rational. It works for all 6 of the parent functions. So first thing we're going to talk about h and the k. So the h and the k is what of the graph? The vertex of the graph. The h represents the x and the y represents the k. Now, for example, my h, just like we do the regular graph, right? The h is going to be moves from the x or the h, goes from left to right, and my k or my y goes from up to down. Does that make sense? To help you remember, the h and the k are the same thing. The h and the x are the same thing, and that goes from left to right. The k and the y goes up and down. Okay? So that's your vertex. Now, how do we get the vertex? If the function is in this format right here, ax minus h, and then of course whatever it is, in this situation squared, plus k, what you have to do is, if h is positive, you switch the sign. Switch the signs, the very, very key point. Switch the sign, and it moves to the left. So if it's positive, you switch the sign, it becomes negative, it moves to the left. My next thing is, what if h is negative? If h is negative, it does the same thing again. Switches the sign, and if it's negative, then it moves to positive, and it moves to the right. Now our next thing is going to be my k. The k doesn't change at all. The h is the only one that changes. Now the k is going to move up and down, and this goes back into what I was saying. This is going to be your y-axis. And this reason why this one moves left to right is because it's going to be my y-axis, my x-axis. So the h is the only one that changes sign, and the k keeps the same. Now, what are we left with? We're left with one more thing, and we're left with the a. So let's change the color for 1 second. I'm going to switch to orange. So the a, value, if the a is positive, it's going to face upward. If the a is negative, then it's going to face downward. Very key important things right here. So for example, if I have a quadratic and it makes a u, if it's positive, it's going to face up. Now if a is negative, then it's going to face in the downward direction. Now, what happens if my a is greater than 1? If it's greater than 1, so that would be like 2, 3, 4, so basically 1 and up. Well, not actually no 1 and up. Anything greater than 1 and up. So like I said, 2, 3, 4, then it's going to shrink. Now if a is less than 1, it's going to stretch. So what I mean by that is shrink. It means it's going to get closer to the y-axis, and when a is less than 1, it's going to get closer to the x-axis, so it's going to get wide. Alright? So that's what I mean by stretch. Now, hopefully this makes sense. Let's do a couple examples so we can get it all together. I hope you guys are writing this down. Alright, let's do an example. First things first, we have this right here. So let's make sure we get everything straight. Our first thing is, what's my a in the situation? My a is going to be, and we had before, my a is going to be right here. So that's going to be it's going to be 5. Now my h is going to be, as I said earlier, it's going to be the 4. But what do I have to do with the 4? The 4 has to switch signs so that negative 4 turns into a positive 4. And then of course this right here, this is going to be my k, and the k is going to stay the same. And when we bring it all together, we have our vertex is going to equal to 4, negative 5. Alright? So 4, negative 5 is our vertex. And what graph is this? Let's go back to part 1. What graph is this? Because it's squared, this is going to be our quadratic. Or if you would have put parabola, same thing. Now our next one, number 2. Number 2, oh, one more thing I forgot to mention. Because the a is the 5, what happens to the graph when it's 5? It's going to do what? It's going to get closer to the x-axis or get close to the y-axis or get closer to the x-axis. In this situation, because I have a 5, that means it's going to shrink, so it's going to get closer to the y, so it's going to get smaller. So this also lets me know that this is going to shrink. Alright? So this is my A, this is my vertex, it's going to shrink. In this situation, it's going to go to the right 4 and down 5. Next one. My A situation is going to be a half, and because of that, it's going to get wider because it's less than 1, so it's going to stretch. And then my H in this situation would be a -2, and my K in this situation would be a +5. So then I get a -2, and I get a +5. So this graph is going to go to the left 2 and up 5. And the name of this graph right here, because it's a third, it's going to be cubic. Alright? Now our next graph. Our next graph is going to be, it doesn't have any exponents in this situation. It doesn't have an exponent. So if it doesn't have an exponent, then it's going to be linear. Now what's my A in the situation? The A in the situation is going to be a -2. Now because it's -2, I look at this negative. This tells me that it faces down. Now a lot of y'all may say this is -2, so it's less than 1. But I don't look at the negative part, I want to look at the 2 itself. Because this 2, this graph right here is going to get closer to, it's greater than 1, the 2, so it's going to go closer this way, so it's going to shrink. Now my H in this situation is going to be, this is -3, so it's going to turn to a +3. And my K in this situation, do I have a K here? Do I have anything written here? No. So my K is going to be 0. So my vertex will be 3, 0. It's going to shrink because this negative is going to face downward. So this is a linear graph. So the linear graph would look, since the linear graph is going to face downward in this direction. Now our next one, our rational graph. This is going to be our rational graph. Now what else do we know about the rational graph? The rational graph is going to have our A's right here. So our A is going to be equal to 3. Our H, this is +2, so our H is going to be a -2. And I have a K here, so this right here is going to be my K. So the K is going to stay the same. So our vertex in this situation is going to be -2, 4. And because of this 3, we know what's going to happen with the 3. Because this 3 is going to do what? It's going to get closer again, so it's going to shrink. It's going to be a very thin graph. Lastly, now we got number 5. Our number 5 is going to be, because these absolute signs, it's going to be absolute value. Absolute value makes, so what does the graph look at? Absolute value is going to have a V shape. Right? Absolute value. The A in the situation, do we have an A in the situation? We don't have an A written there, but because there's nothing there, we can assume that it's going to be 1. It's an understood 1. The H in this situation, because it's a +2, it's going to give you a -2. And because my K, do I have a K here? I have no K here, so this will give me 0. And when I bring those together, I get, the vertex will be -2, 0. Alright, absolute value, my A is equal to 1, my H is equal to -2, my K is equal to 0, and -2 is going to be my vertex. Now my last graph. My last graph is going to be equal, this is a square root, so it's going to be a square root graph. This graph looks just like a lowercase r, so it's going to look just like this. And do we have an H here? No, we don't. So my H would be 0, my K would be -5, and do I have an A here? No, I don't. So my A also in this situation would be 1. So when I put it all together, when I have a 1, it means that it doesn't shrink or shift, it stays the same. And my vertex would be 0, -5.